Hello, everyone. My name is Hao Tianchen. Today, I would like to present on behalf of all the authors of this paper, Contextualized End-to-End Neural Entity Linking. We group of researchers and engineers at BlackRock, and it's our pleasure to share our research in this conference. So first, let me introduce you the problem that we want to solve in this paper. Supposedly, you are given the sentence, "The Times began publication under its current name in 1788." We would like to know if it contains any named entity, and if so, what's the entity? And in this case, the Times could potentially refer to a British newspaper, the Times, or it could refer to an American newspaper, the New York Times. The task here is called entity linking, which has two subtasks, mention detection and entity disambiguation. Mention detection needs to locate the beginning boundary and ending boundary of the entity. And then for each mention found, entity disambiguation is a task of linking each mention to a unique identifier in a knowledge base or entity universe. We approach the problem by an end-to-end model. So our mention detection and entity disambiguation share the same knowledge and optimized by a single loss function. On the other hand, some of the previous pipeline models would have separate models for mention detection and entity disambiguation. Another common approach employed by past literature is the usage of handcrafted candidate sets or candidate generation process. So in that case, for each mention found, a finite size of candidate entities is first generated, and then the model will find the best entity inside this set. For our model, we have the option of not using candidates at all. And let me summarize the contribution of our paper. We propose a new end-to-end differentiable neural entity link model that jointly performs mention detection and entity disambiguation and achieves state-of-the-art performance. We also study the performance of our model when candidates are removed, and it allows extending EL model to field where candidate sets is not available. Let's jump into the details of our model. The entity universe of our model is 1 million most frequent entities in 2018 Wikipedia. The entity representation learning is beyond the scope of our research, so we just use Wikipedia to whack entity embedding. The text encoder of our model is BERT-based version. The data is tokenized by cased word-based tokenizer. It's similar to BERT performing NER task. Note that BERT does come in two flavors, feature-based and fine-tune. Feature-based is basically freezing the BERT parameter during domain-specific tasks, and fine-tune will allow the parameters to adapt to the domain-specific task. So here's a graph of a model. This is the input layer of word-based tokens, and this is the BERT text encoder layer. And on top of the encoder, it's a layer of dropout to control the overfitting. And finally, we have two separate task heads for MD mention detection and ED entity disambiguation. MD tags is modeled as a LB tagging, i.e., it's a sequence labeling task. So its head is one layer of feed-forward neural network and softmax activation over three class IOB labels. And on the other side, ED tags head is one layer of feed-forward neural network with hyperbolic tangent activation. The head projects to the entity embedding space, and the model finds the entity closest to the predicted entity embedding by some distance measure. And together with output from both MD and ED heads, we could assemble the predictions and finally get our entity linking results. So the model is optimized by a weighted loss between MD loss and ED loss, parameterized by a lambda. Our MD has a cross entropy loss between predicted distribution and actual label, and ED use cosine similarity score between predicted anti-embedding and actual anti-embedding. Next, let's discuss the experiment details. The dataset that we use is IDA, which is a standard benchmark dataset in the entity linking field. It's a collection of news and has split it into train, validation, and test parts. As for metrics, we evaluate our model by out of sample, strong matching, span level, in KB, macro and macro F1 score. So every word matters here. Strong matching means that entity mention spans has to match exactly at character level, and overlapping doesn't count. Span level means that confusion matrix statistics, i.e. true positive, false negative, are calculated on span level, not word level. And in KB means that confusion matrix statistics are calculated for labels where valid entity annotation is available. Macro and macro are just two ways of do average. F1 score is a harmonic mean of precision and recall. Note that unlike accuracy metric, F1 penalized tagging non-mention span as entity mention. As I mentioned before, we have the option of not using candidate sets. And in that setting, the candidate set is effectively the entire entity universe. And we could also use the IDA candidate sets that comes with the IDA dataset. And it would make our model more comparable to other work. For more details on hyperparameter and training, please refer to our paper. Let's move on to the results section. We have compared our model with 6 recent entity linking models, and here's the validation and test split results on the metrics we mentioned before. As you can see, with IDA candidate sets, we outperform other models by a margin. Additionally, we don't arbitrarily limit the size of candidate sets. So our candidate sets could have 20 to 30 candidates on average. And without candidate sets, our performance is just on par with recent work. The performance drops as expected. It's a more challenging task to find the best entity in the full universe. There are drops in performance between validation and test split. This indicates a potential problem of overfitting. We're unsure whether this is due to the bird or the downstream model, and this does require further study. We also performed a simple ablation study by replacing Wikipedia to WAC entity embedding to fast text embedding. So fast text embedding is just simply encoding Wikipedia entity name string using fast text. Surprisingly, it still maintains a relatively strong performance. This points to the possibility that um, either bird likely already has entity knowledge, or many IDA dataset mentions are easily linkable by simply considering their surface form. So lastly, let me reiterate our contribution of this paper. Firstly, our model is an end-to-end differentiable neural entity linking model that optimizes mention detection and entity disambiguation tasks at the same time. It achieves state-of-the-art performance. Second, it's possible to remove candidate sets during both training and prediction. Our model efficiently disambiguates 1 million entities in the universe. As for future direction, we think it would be really interesting to investigate whether bird understand entity without any entity representation learning. Also, entity linking communities would benefit by reducing dependency on candidate sets. This could make entity linking models more easily comparable. And with that, thank you very much for your attention. Please feel free to contact us in case if you have any further question.